English for professional mechanical engineers. I'm happy to have this chance to speak to you today about the microfabrication. My name is Yiju. In today's lesson, we are going to introduce the concept of microfabrication. Why do we learn microfabrication? As you may know, Taijidian or TSMC, Taiwan Semiconductor Manufacturing Company, is the most well-established company in Taiwan. Do you know what kind of technique which makes TSMC so well known? This is about today's topic, microfabrication. First of all, where can we see TSMC's products? Okay, it could appear in smartphone, camera, and gaming devices, etc. Or even in a car. There are many tiny sensors and actuators which makes the car smarter and better. As you may be aware, TSMC products are in our daily life and create foundation of modern society. Are they very important? Do you know which technology make our world so different? It is called microfabrication. It is a process to fabricating miniature structures of micro scales. It means 10 to the power of minus 6 meters scales and smaller. There are many terms for microfabrication like micro-electromechanical systems, MEMS, microsystem technology, MST, or nanotechnology. Nano means the dimensions are even smaller, 10 to the power of minus 9, while micro is 10 to the power of minus 6. As a result, nano is 1,000 times smaller than micro. Here is a table. It demonstrates the sizes between different scales. The top row shows the dimensions from 10 to the minus 10 to 1 meter. The second row is the example of objects, atom, molecular, and virus. They are at the nanoscale. Bacteria, human hair are at the microscale, and human tools, hand, and legs are in the traditional engineering linear dimensions. The bottom two rows show how to observe and fabricate at such scale. One section of this digital course introduces electron beam microscope. It's a device which can observe tiny things like atom, molecular, and virus by using electron beam instead of light. Microscale is the limit for light to see things. Electron beam is the medium for observing things at the nanoscales. Right. Was that clear? Here's a question about this table. This table doesn't use the term microfabrication to describe fabrication methods for microscale objects. Can you tell me what methods can fabricate microscale objects? Okay, have you figured out the answers? There are 3 fabrication methods over here dealing with microfabrication. When you look at the scale between 1 to 100 microns or micrometers, you will find silicon layer technologies, Liga process, and the precision machining. They all belong to microfabrication technology. But for this introduction level course, we will only focus on the one which is most well known, silicon layer technologies. Now, what's next? For the microfabrication technology, it includes 3 categories: patterning or photolithography, deposition, and etching. These are also the topics for the next 3 sections of this video. However, before we move on to these 3 fabrication technologies, let's look at why is Taijidian TSMC called Taiwan Semiconductor Manufacturing Company. What is a semiconductor? Okay, A semiconductor is a material which has an electrical conductivity value falling between that of a conductor like a copper and an insulator like glass. Does that make sense to you? A conductor can conduct electricity like copper or iron, while an insulator does not conduct electricity like glass or rubber. On the other hand, a semiconductor is something in between. It can conduct electricity, but it's not so effective to conduct electricity like a conductor. However, it does allow electricity to go through it. So, would you please give an example? Like copper is a conductor, glass is an insulator. What substance is a semiconductor? Okay, the most famous semiconductor is silicon. Of course, it's not the only one, but it's the one most well known because it changes human society a lot. These are two pictures of silicon. But why do they look so different? Okay, the left one is silicon ore, a raw material without any chemical or mechanical process, while the right one is single crystal silicon, which has been fully processed and is used in TSMC, the semiconductor industry. Silicon occurs naturally in the forms of silicon dioxide and various silicates, and hence it must be purified. But how the silicon ore is purified into silicon wafers? Let's look at the next figure. Okay, this figure shows the process of silicon from ore to wafer or substrate. It has 3 stages. The first one is from raw material silicon ore to polycrystal. The second stage is from polycrystal to single crystal. Then the final stage is to slice the silicon rod into individual wafers. So, from ore to polycrystal, from polycrystal to single crystal, and from single crystal to wafers. These are the 3 stages. Right, here are the process details of the 3 stages. The first one is heating. Heating produces 95 to 98% polycrystalline silicon. The second stage is called CZ. Look at the figure to the right. Liquid silicon at the bottom, a rod at the top, rotates at the speed of 1 revolution per second and pulling up 10 microns per second. This process can grow single crystal silicon rod. Then, at the final stage, this rod slices into silicon wafers. These are photos to demonstrate the process of the CZ method. It starts from the photo at the top left corner. A high temperature liquid silicon at the bottom, and the rod is rotating and pulling up. Next, as long as the rod is pulling up, liquid silicon is crystallized at the bottom of the rod. This is the nature of material when it cools down. If a liquid silicon crystallizes, it turns into pure crystals. And eventually, a pure silicon rod is obtained, as you may see the bottom left photo. Okay, here is a photo of a giant silicon rod with an engineer measuring its properties. And the engineer is well suited. This is a requirement for this kind of a working place called clean room. It is extremely clean, a dust-free room. Do you know why? Hope you can figure it out by yourself. Finally, after slicing, pure silicon wafers are ready for TSMC Taiwan Semiconductor Manufacturing Company, to produce key components in the smartphone, camera, gaming devices, and cars. Is not the whole process to prepare for the silicon wafer a big challenge? In the next 3 sections, we will introduce how to use these wafers to pattern, deposit, and etch silicon wafer into microscale structures. Are you ready for that? Alright, before we move on to the next video, let's summarize what we have learned today. Number 1. Microfabrication is a process of fabricating miniature structures of micrometer 10 to the power of -6 meter scales and smaller. Number 2. This technology is applied to make smartphones, cameras, gaming devices, and so on. Okay, the third one is a question. What are the 3 stages to produce pure silicon crystal single wafers? Right, the 3 stages are heating, CZ method, and slicing. Have you got them correctly? So, this is the end of this section, Introduction to Microfabrication. So much for today. Thank you for watching. Hope you have learned something useful from today's lecture. We are going to talk about the key part of microfabrication in the next video, photolithography. Have a good time and see you in the next video. Goodbye.